So one of the big questions in injection molding is, are electric molding machines better than hydraulic molding machines? Let's look at a few key points here. Electric molding machines are more energy efficient, meaning they use less electricity to produce the same parts. Electric molding machines are more repeatable than a traditional hydraulic machine. Electric molding machines are cleaner. There's not the oil that leaks out of them, nor do they aspirate or spray oil into the air. It's important for clean room applications. Electric molding machines are more quiet than hydraulic machines. Electric molding machines typically require less maintenance. On average, electric molding machines have faster dry cycle times than hydraulic molding machines. Dry cycle time is the amount of time required to close the clamp, open the clamp, and eject a part. It doesn't take into account injection. It's really about the clamp, about how fast you can open and close the clamp. And typically, electric molding machines can do that much faster. Electric molding machines, however, cost more. Now, this is one of the drawbacks, and there are some others we're going to talk about. So, and we're going to continue to talk about this. Are electric machines better than hydraulic machines? Well, in the respects shown here, they are. But molding machine cost is a big one. And in a lot of applications, you really need to have some of these things up in the top to justify additional cost of an electric molding machine. However, the prices are becoming closer. Okay, so why do hydraulic molding machines still exist? Well, low initial cost. For special applications, they really are the better machine. It is really hard to beat the energy density of a hydraulic system, especially an accumulator-assisted hydraulic system. So this is where you pump hydraulic oil into essentially a big balloon of hydraulic oil under pressure. And so say for a packaging application where you're going to inject a tremendous amount of plastic very quickly, a hydraulic accumulator injection unit is able to do that without a really big pump, but with the accumulator really quickly inject that plastic and do it very well. Another case where some electric machines are not quite so capable and hydraulic machines are really pretty good is when you have high hold pressures for a long time. So long hold time at high pressures. Most hydraulic machines are really pretty good at that. If you get a hybrid machine, they're really good at holding that long hold pressure for a long time at not very much energy cost. So then the other thing we have here is hybrid machines. Hybrid machines are a combination of servo-driven, electric servo motor-driven hydraulic pumps and hydraulic actuators that combine some of the energy benefits of an electric system along with some of the low-cost actuators of a hydraulic system. So these hybrid machines are pretty good at reducing energy costs. They don't come quite to the place of an electric molding machine, but they're much better. They do have some reduced maintenance costs. When you look at the maintenance cost of a hydraulic system, a lot of it is due to, well, in the actual actuators and valves, a lot of it is the servo valves that are there. And those servo valves are very sensitive to contamination in the oil. Many hybrid machines eliminate some of those, many or most, if not all of those servo valves and replace them with simply directional valves, and so the cleanliness of the oil becomes much less important, and so maintenance goes down because of that. Hybrid machines certainly can be quiet, very similar to an electric molding machine. Sometimes not quite so quiet, but they can be quiet. And hybrid machines can be made to be more repeatable, and frankly, really good controls on a hydraulic machine can be very repeatable as well. So there is still a place for hydraulic molding machines. In fact, there are good applications for both. Now, granted, the difference between them is narrowing as electric molding machines become better. But the hybrid machines and the hydraulic machines continue to be very successful as well. They're still very popular in Europe, but electric machines are very, very popular in Japan. And here in the United States, we're seeing electric molding machines displace hydraulics in a lot of places. One additional place where a hydraulic machine has a definite advantage: when you have a mold that has one or two or more hydraulic core pulls, so these are molds that have a hydraulic actuator inside the mold. when you have a hydraulic core pull, if you have a hydraulic molding machine, the hydraulic system is already there to drive them. If you have an electric molding machine, you either have to convert those core pulls to a electric driven system, which is really quite expensive still, or you have to get an auxiliary hydraulic unit to drive those hydraulic core pulls. So that once again increases the cost, it adds an auxiliary system, and there's some disadvantages of having those. There, however, are more recently electric machines that are hybrid in the sense that all the machine motion is done electrically, with the exception of one or two axes. For example, it's not terribly uncommon for the pull-in cylinder, the cylinder that pulls the injection unit toward the mold, for that to be hydraulic. And sometimes the ejection system to knock the parts out of the mold is hydraulic. And so sometimes you'll have a hybrid system that some of those minor axes would be hydraulic, and then the system is also there to be able to run the hydraulic core pulls as well as those other hydraulic pieces, giving you the advantages of both systems. Okay, so servo motors, they seem to be at the heart of making things more electrically efficient. A servo motor is really a device that that allows you to electrically provide motion to a system. Now, most servo motors, in fact, the servo motors that exist in most molding machines are rotary servo motors, like this guy that we have here on the screen. So this device takes electrical power in through one connector here and provides signals of where the motor is out of this connector. And this motor, in combination with a servo drive, is able to very accurately position the motor shaft, which is connected to other things, our actuators, or say our injection unit, our screw motor, our clamp, or ejection system, all those things. The combination between the motor and the drive allows us to have very precise motion with very good electrical efficiency. In a hydraulic system, the control, in a full hydraulic system, the control of actuators is based off of the opening and closing of valves at different rates to allow hydraulic fluid through those valves. In an electric machine or in many hybrid machines, that motion is regulated by the servo motor. And servo motors are very high performance at doing that job. So we've got So the last page showed you about how motion, the rotary motion of those servo motors is converted to linear motion through either a ball screw or a roller screw. And those are very energy efficient devices, converting 97 to 98, sometimes 99% of the energy, rotary energy, into linear motion. Okay, so why does this matter? Why, as somebody who's involved with the molding industry, do you need to know about electric molding machines and how they're different? One key thing here is, as you're around molding machines and being involved in processing, or potentially in a position of specifying what kind of a molding machine to use for a mold, you need to be aware of the fact that for long hold times, especially at high pressures, can result in overheating of the servo motors or drive electronics in an electric molding machine. This might become a problem if you're injecting, for instance, polycarbonate, and either the person processing the mold doesn't understand that hold pressure doesn't need to be that long, or the part isn't designed very well, lots of other reasons. But if indeed the molding machine is set to have high hold pressure for a long time, especially on older electric machines, it's pretty common for those motors to overheat. And repeated overheating of those motors or drives can damage them. And so somebody who doesn't know what they're doing processing a mold, and they have a long hold pressure for a high hold pressure for a long time, say that they have a 24,000 psi plastic pressure hold pressure, and they've got it set for 15 seconds. Well, 10 seconds into that cycle, sometimes after the machine's been running for a few minutes, that injection motor may overheat, and it'll send a signal to the drive that says, hey, I overheated, shut down, and it'll shut down, and it'll give an error. And if somebody's frustrated and they don't understand, they'll reset the molding machine and start it again, and it'll happen again, and maybe they'll do it again. And when that happens, the way that the control system is set up, it's not really set up to handle that. And so what ends up happening is, before the motor can detect that where its temperature sensors are overheated, the part that matters is already overheated, and you can fry the motor and or the drive. This is the electronics that drive it. And it wouldn't be uncommon on a 200-ton press that replacing the injection servo motor and drive may be $20,000. So it's something that you need to be aware of. Now, newer molding machines have been designed with this in mind, and they have better servo motors, they have better control systems, and this is becoming less of a problem, but it's still a problem. And associated with this is the fact that many electric molding machines have a lower maximum hold pressure than their maximum injection pressure. So this is one of the things that molding machine manufacturers have put in place. They say, they didn't really intend hold pressure to be as high as that maximum injection pressure. So some of them now have really great servo drives, and they do a really good job, and they have good control systems. And as long as you operate within that lower maximum hold pressure, which their control is set up so that you can't set it higher than that, then you're not likely to have the servo overheating problem. But it does lead to the fact that on traditional molding machines, in hydraulic molding machines, where hold pressure could be set as high as maximum injection pressure, specifying what molding machine you could use for a mold was relatively easy. When it comes to an electric molding machine, and when you buy a new electric molding machine for a job, and there's going to be high hold pressures involved, this is something that needs to be looked at carefully. Because most of the time that maximum hold pressure isn't too much lower, maybe 20% lower than the hold pressure, but sometimes it's a fair amount lower than that. Okay. Another thing is jerky motion will cause premature failure of the actuators on the molding machine. And so those ball screws and roller screws to a less extent, ball screws to a higher extent. And you have a mold that, for instance, halfway through its motion has a little hiccup in it, and it bounces, or there's a bang. Over time, the balls will actually wear little marks and divots into the screw. And over time that will cause problems. So it's a bigger problem than it is in hydraulic machines. In fact, hydraulic actuators are really pretty good at taking impact, and sometimes molders will use, for instance, the jerky motion that they can produce with the hydraulic clamp opening and or ejection motion to get parts to come off the mold. And hydraulic systems take that really well. If you try to do the same thing with an electric system, gosh, it can really be hard on it. Lubrication of ball screws and roller screws is essential. If that lubrication does not happen, those actuators will fail prematurely, and they're not inexpensive to replace. The ball screws and roller screws, by and large, are a large portion of the reason why electric molding machines cost more to purchase rather than hydraulic molding machines. And so just generally, they're not very forgiving when you make a poor setting or have jerky motion. There's a little bit more finesse involved in setting up an electric molding machine. So that's generally a wrap of things. That electric molding machines are more efficient. They're quieter. They have lower maintenance. They have better repeatability. All of these things, and so performance-wise, yes, they generally are higher performance machines, with the exception of special applications where hydraulic actuators are better. But generally they're better, but there's an additional price. And as years continue on, we'll see that price narrow, but we'll also see better hybrid drives that will narrow the performance difference between a hydraulic machine and an electric machine. So that's generally the summary of that.